Just wanted to let you all know that this meeting is being recorded. We'll be able to upload it to our website afterwards. And yeah, we'll be able to get started here in a minute. Can you all hear us okay, those online?
Yes, loud and clear.
Great.
Yes.
Perfect.
Okay. Are you ready, Brad?
I am always ready.
Okay, great. We're happy today to host Brad Beginning, Chairman of Alpen, the high performance product, mostly focusing on the administration product. Been around for 40 years, right? The company, Louisville, Colorado. So we will talk to us today about the administration system, especially focused on the retrofit application. So the hope is you'll get some idea about what's out there and what is the performance and potentially the cost benefits of retrofitting windows. Brad, you have the floor.
Thanks. And this will hopefully be fun. And I will start out by, I'll get to our company a little bit down the road as opposed to starting out with our company. But when I was in school, I sucked at math, science and such. So I've studied history and political science. I love history. So a lot of when I start things, I want to give you a little base historically to kind of bring us up to current technology, because I think it's important from a grounding perspective. This is what, let's see here. This is what we're going to try to accomplish today. Really two different elements of the investigation. I'm going to start with a brief discussion around, and it's going to be quick. We're going to jump 5,000 to 10,000 years at a time, because that's sort of the pace of window and glass technology development. We're going to talk about where we're at right now, and then I'm going to jump back and talk about how people deal with window retrofits. And then we're going to talk about some of our company and our company solutions, but it'll have more relevance when we get there. And we're going to talk about windows as part of the ecosystem of retrofit applications. Look at some of the options and then talk about some of the more subtle things to keep in mind that I hope have value. We're going to jump right into it. Let me start by just suggesting a truism that glass technology has developed very, very slowly. I'm a little bit of a history nerd. We're going to talk a little bit later about thin glass technology, and I'll show you some samples. If you go to New York and you're bored between New York City and Niagara Falls, the #1 tourist destination is the Corning Museum of Glass. It is unfriggin' believable. But in it, they have literally as much information about glass and glass technology. So my second slide, I can verify because I saw it, is when really what we call window glass today was really developed and began to commercialize during the Roman era. Prior to that, you can see where we were slightly before that. R1, do you all know what R1 or U values, what's the foundation of everybody's technology, everybody's understanding here, the basics of Windows and all that? So R1 is obviously the inverse of 1. In this case, we measure window performance in U value for the sake of simplicity, although it's not a perfect correlation. We'll talk about R value. It's just people feel more comfortable than sort of the fractions. A single piece of glass is R1 performance, as you know. R2, this is the original patent, 1865. Thomas Stetson developed, or at least patented, putting two pieces of glass together. I'm not going to bore you with 1865 up through all the machinations of how it got to be where it is, but this is really the beginnings of what we consider to be R2. The very basic insulated glass panel was really developed in, I'd say, the 40s and 50s with a product called Thermopane that was kind of goofy. But we continue trudging forward. These are, I'm an older guy. You guys are young. You may not even recognize these people. Jimmy Carter just died, a couple weeks ago. Really pretty influential in the world of energy efficiency. One of my favorite PowerPoint slides is I said, this is the person that's most responsible for high performance windows. And I showed Dick Nixon, Tricky Dick. And it's because during the 1973 Israel Arab conflict, he loaned Israel $2.7 billion, which set in motion OPEC stopping shipments and embargoes. And we had lines miles and miles long of people. You've seen it from time to time in the pandemic. But that really started the DOE, and it started the progression of more window technology. Way back in that time period, you can see that clear glass was really dominated. Double clear glass really dominated the glass industry. You then got to tints, but low E emissivity coatings, which are on every window today, really were developed out of early DOE grants and technology that was commercialized back then. But you can see how even double pane clear glass didn't even get to a dominant position until the 83s. Every window sold at least north of really super temperate climates is double pane. Low emissivity coatings became a thing out of the DOE research. It was rapidly commercialized, but it also, shockingly to me when I researched it, didn't even have 50% market share until 2003, which is fairly recent for me. Down at the very bottom, you see this little blip here? That's triple pane market share in the United States. Trick question, in Europe, what's more expensive, double pane or triple pane? Double pane, because it's an exception to what they do every day. It literally is. Window designs, that's glass. That's coatings of glass and glass technology. Window designs have not changed much in the United States. This is a uniquely United States thing as well. You may recognize the double hung window there on your left. It originated in the colonial times because it was kind of our version of air conditioning back then. You didn't have air conditioning, obviously. If you open the bottom and the top pane, you got convective currents. That is still by far the most dominant window sold in the United States. Not the rest of the world. It is uniquely United States design. You see these little, what are called grids. You've seen them all over town, and many of you probably grew up in those areas. I don't think you see a ton of them in Europe. Why do we put grids on windows? Stupidest thing I've ever seen. They're fake, and what they're doing is they're simulating a period of time that goes back to the Roman times when glass was made that big and it got puttied in place. That's what we're simulating. That's what's all over. If you go to New England, that's what they sell in windows. It's the craziest thing I've ever seen in the world. But it is what it is. Now let's talk about modern windows. Vinyl windows have almost 78% market share in the United States, the evil vinyl window. In 1995, this was the state of the art of what the very, very best windows looked like. Gas fill between window panes, argon gas fill, low E coatings, double pane, higher and higher performance spacers. But that's what the prototypical, what would be called energy efficient window looked like. 2024, that's what the prototypical energy efficient window looks like. See the differences? Mm-hmm. No, you don't. The world is going through some really massive changes right now, and we can get to that if we have time. But my point is that what has happened is that energy efficient design from almost 35 years ago has now become ubiquitous. That is what almost every window looks like in the United States. Low E coatings, double pane, narrow window pocket, because remember, we like sliding windows. They have to go past each other, so they don't accommodate wide pockets. In Europe, what do you have? Wide pockets, wide pockets, because you have wide walls. You don't have that sliding sensation. All right, cute lesson windows, cute lesson. TikTok, let's go. Let me get to the, you guys ever seen Stripes? Anybody recognize that Lighten Up Francis, or is that's, you got to watch Stripes. Bill Murray is funny. In the commercial or non-residential built environment, this is actually a very important thing to understand. It is well understood and accepted that by far the biggest challenge is energy efficient windows. Lots of people like to call it different things because some things aren't quite so PC, energy intensity, operational carbon, sustainability, whatever. But poor performing windows in the built environment, in the commercial built environment, is a massive problem. We're going to talk about it. These are oft recited statistics. 8% of the surface area of a building is on average covered by windows or glass, and 45% of the energy loss goes out those windows. This is US building stock, 5.5 million buildings, 40 billion square feet of openings. In the background is the first spec net zero commercial building ever built. It happens to be here in Boulder, happens to have great windows from Alpen. Facts that may surprise you. Once again, we're going to make this relevant here. 50% of commercial buildings in the United States, based on surveys from NREL and LBNL, et cetera, give or take a couple of percent, have what are considered to be very poor performing windows. 30%, shockingly, are still single pane today. Single pane in all kinds of environments. The other 20%, typically non-thermally broken aluminum, double pane, probably a failed IG, but 50% of all buildings in the United States are what are considered to be poor performing. Anybody that's watched late night TV, pays attention to commercials, can't help but be bombarded by buy one, get one free, replace your windows, let Build Right come in, da, 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 da. There's a very mature, well-developed residential replacement market. If you want to replace your windows, all you got to do is call any of, say, 700 numbers. They'll finance it. They'll come in. They'll make it all work. I have seen, we do not do this at Alpen. I've seen the heavy-handed sales techniques of vinyl residential replacement windows. It is a very interesting phenomenon. They try not to go to a one-legger for a presentation. So if you really want to get a replacement window, good luck getting it if your significant other is not there to make a decision, because they want to close you the first night. You're called a one-legger if you're only one half of the pair, because you can't make a decision without the other half. Of all of the commercial buildings built in the United States, I think it's between 8 and 9% have ever replaced their glass or windows. It just doesn't happen very often. We're going to talk about why, and then we're going to talk about what to do about it in a moment. And this fact kind of makes sense, but it was surprising when I first heard it. 90% of all commercial buildings that will exist in the United States in the year 2050 are already here. We are a lucky company to be participating in all kinds of high performance stuff. We do the coolest projects. I love them, but they're not really where the problem is. Why is the retrofit market broken for the commercial world? We talked about some of those statistics. Why does everybody not just replace their windows when they need to? Replacing commercial windows can typically be more expensive than a residential. Not always, depends on the building, but if you're going to replace a commercial aluminum single pane window system in a multi-story building, it's typically more expensive. If you have occupants, it's either self-occupied or you have tenants, you can't have them work around the construction. You got to figure out what to do with them. It's kind of a painful process. Real estate or commercial real estate is a very efficient, capital sensitive business. If you have extra money, you're not typically trying to find a way to dump it into your building as you might your home because you live there and spend so much time there. And there's lots of other challenges in particularly historic structures around everything from historic preservation, authenticity to just basic old structural problems. And it's a problem. Consequently, although there's a lot of window companies and glass companies that do a lot of business on the commercial side, it's hard to kind of build a real workhorse model around that system. So people tend to be a little more specialized because people frequently just don't necessarily replace their windows when they have to. It's creating a bigger and bigger and bigger issue, particularly with the pandemic, a mass evacuation of commercial office buildings for the first time. People are talking about a blight on the world and massive disruption in sort of the commercial built environment, people having to give back their buildings to the landlord, move out, redesign them, try to figure out how to make them residential. Because a lot of these buildings, they're not just unoccupied, they're really not comfortable, and they're old and they're expensive to maintain. And it's becoming a real systematic problem. We'll see who wants to step up and deal with it. These are traditional commercial retrofit solutions. What do people do? You can't literally have windows or glass falling out of your building, so you got to do something. You got to periodically pretend to do stuff. So this is a broad range of things that people do over time with some analysis. I'm not going to go through it in great detail, but I do know from years of now of putting time and effort into this, that this is really the only three things people have historically done. If you have a building, a major commercial office building that was built with clear glass, I can almost promise you it not only has applied film, solar control film on it, but it's probably been replaced several times. That's the number one thing people do with buildings wherever they can. They put applied film on it. They replace it every 10 years. And all it does is manage a little bit of the solar intensity. The film gets better and better. It doesn't really improve insulation. Weatherization, very, very common. You don't see it, but where you have leaking older windows in commercial buildings, nothing beats a caulk gun and some silicone to go around the edges. Sometimes we replace weather stripping and pretend to kind of jazz things up. And then by far, the number 1, 2, and 3 favorite thing people do to fix their windows, they put new window blinds over them periodically to make them look better. Not going to get into a lot of detail here, but my point is when you're looking at cost versus payback in the commercial world, you don't see a lot of products up here. They're either inexpensive or they're very expensive but have very long paybacks. So it's a really, really challenging situation for an economic investor that has buildings, and it's become very, very deep and challenging problem on a much broader scale. Have I depressed you enough yet? All right. It's not all bad. Let's talk about Alpen. Who is Alpen? We're a 44-year-old company. We are now in Louisville, Colorado. I was at the National Glass Association conference for the last 3 days. You always had name tags, and everybody asked me, how is it in Kentucky? I said, no, Louisville, not Louisville. And we manufacture high performance windows, doors, and insulated glass products. And then my favorite product is our secondary window product that we'll talk about in a moment here. We uniquely use thin glass. We'll talk more about that in a moment, but we're really a proud, fun company going through a massive growth curve right now. The founder of the company is 82 years old, I think. Works harder than anybody I've ever met. Can't keep up with them. But our running joke, I've been there 17 years. And I was CEO up until last year. Now I'm chairman. Means I get to work on more fun stuff. Great new CEO. It took me 3 years to get him hired, but I thought I was going to be able to not work so hard. Not true. But we are having a lot of fun, and we are the proud recipients of a DOE matching grant under the Infrastructure Act. I don't know if anybody's watching the news lately about that. Talk about it later if you want. I talked about the state-of-the-art window being R3.5. That's kind of the case. There are triple pane windows. Some of the big window companies have small positions of triple pane windows. Our competition has been far and away for the last 10 years, way more focused on imports from Europe and to a certain extent Canada, but to a lesser extent. But we're an innovating company. We brought to market the first full frame R10 window, U-value 0.10, back in 2016. And about 25% of our products are quad pane products right now. We serve the residential and commercial markets with windows and doors. We're about right now evenly split between residential and commercial buildings. We make secondary glazing products. I'll talk more about in a moment. And then we have always had kind of at our core competence, high performance glass. We used a suspended coated film product called Heat Mirror for, it was retired after 44 years. On Monday of this last week, we made our last heat mirror unit. We now are making thin glass, and we'll talk more about that. We still love heat mirror. We were lucky enough to replace all of the windows, not the windows, the glass units in the Empire State Building by taking the glass out, cutting, it was double clear glass and a pretty good frame. We cut it in half. We built a little factory on the 5th floor of the Empire State Building. That's why we have that picture there. Then we made them into triple pane units. They put them back in the windows. Very proud of that. That was almost 12 years ago. We are thin glass centric. What does thin glass centric mean? All of our products have at their core an element of thin glass. And I'm going to start passing these around if that's okay. These, and I'll talk more about it in a moment, are sort of like gold right now. It's like finding a big rookie card. We can keep them in stock. I'll talk more about that in a moment. If you take the units out, you have one thin glass triple and a thin glass quad. It's difficult and challenging to really understand what thin glass looks like. Here's a window. You can pass that around as well. And then when we get the windshield, I'll pass that around. But this is a not only we could find a quad in a showroom for it, that's my planning, but you see how the lightweight glass in the middle is really effectively taking a double or into a triple pane. But all of our products, including our secondary window product, use thin glass. What is thin glass? Thin glass was invented, as they keep reminding us, by a fantastic company called Corning. You may associate Corning thin glass with the Apple iPhone. It is a true story that 8 weeks before the launch of the iPhone, Steve Jobs, talking to Corning about something completely different, said, I want to replace this plastic with glass. Can you make it happen? And they did with thin glass. Thin glass. This is a remarkable company, Corning, massive world-class R&D. When do you think they invented thin glass? Hard to think. When did the iPhone come out? I can't even remember, frankly.
2005.
Yeah. They invented thin glass in 1965. And it was a thing. They invented it. They put it on the sidelines. And that's sort of what they do. And if it has to do with glass, when you go to the museum, you can see this fiber optic cord rolled up here that When you put light on one end, it immediately comes out the other. That was 7,000 miles long, wrapped up in that cord. And they are continuing to innovate on lots of product categories, but they invented thin glass. iPhone is one of their most popular applications, but thin glass became very, very widespread and became very, what I'd call, more commercially viable with the advent of something that each of you probably has in your apartments or homes right now, and it's called a flat screen TV. Dramatic increase in the production and lowering of the cost of thin glass. It wasn't just computer screens and iPhone screens, but flat screen TVs dramatically increased the production. And there's really three major window companies now that produce thin glass, and it's a wonderful product. We, in talking to the Department of Energy, Lawrence Berkeley National Lab, which does a lot of the sort of leading primary research for Windows. One of our favorite people was leading. He said, "You guys, you deal with this thin film. You might want to play around with thin glass, and out of pure respect." We said, "Sure, absolutely. Where do we get it?" They told us the three names of the companies. We called them. They sent samples over. We sat in a conference room. And we said, "This is stupid. What a waste of time. It's going to break first time we look at it." The technical people for the glass company said, "No, it's really quite the opposite. It's very flexible and it works really, really well." And we began working with it and loved it. And we got it in really, really big sheets. We did tons and tons of testing. And it allowed us to do something that regular film could not do. And that is grow it at a mass scale and mass production. And that's exactly what we're doing right now. It's very flexible. You would think it would break, right? And we're working with thin glass down to 0.5 millimeter wide. It can go thinner, but that's sort of where we're sort of settling. Most of our glass is 1 millimeter to 0.5. All of our work with Corning is 0.5, but it is this flexible. We have now have 2 million square feet of thin glass in the market, growing rapidly. And we're not the only one. There's now one of the largest European insulated glass unit manufacturers has now announced that they're going into it. There are 2 other window companies in the US that have announced they're going to go into it. And we're hoping we're supplying quite a few more as we move forward. But it's a remarkable product. We are just literally on, what is today? Thursday, on Monday, we turned full production runs on our first of 2 high-speed vertical insulating glass lines. Each of these lines, you're all invited. Come up for a tour in Louisville, not Louisville. And you can see this operating. It is quite remarkable. This machine can produce 1,200 insulated glass units in one shift. Right now, we're producing about 150, well, prior to Monday, 150 by hand on a more manual process. We're putting a second line in Pittsburgh to meet market demand, a lot of it being back in the eastern corridor and places like Boston and New York, where energy codes are a little more progressive. But we're seeing demand from all over the country and into Canada. And we're super happy. We have a 1-month delay on embargoes to Canada. That was pretty silly. Just recorded, don't edit that one out. DOE. But this is what thin glass did for us. It allowed us to automate the production of glass units. The spacer is an extruded spacer. It is really, really remarkable. 2 years ago, there was no equipment manufacturer on the face of the earth that could do this. This vertical line is all over the world. People are using this technology and have for many, many decades. High-speed vertical insulated glass unit manufacturing. You put the glass in, and it does all the magic, and boom, a couple of people down this long, long, long line. Out the end comes a ready to go high-quality insulated glass unit. Nobody knew how to handle thin glass because it takes a little bit of a different technique. There are now 5 of the 5 manufacturers in the world, including some of the biggest, that have now announced they have solutions. So we're putting 2 of the first in the world in up at Alpen in little Louisville. High performance thin glass. I just passed around. You saw hopefully a double. We didn't see a double because we don't do doubles. A thin glass triple and a thin glass quad. Thin glass quad, two thin glass lights, and a thin glass triple obviously being one. Why is it uniquely helpful to the US window industry to have a thin glass quad? Remember what I showed you back in 1700s, those double hung sliding back and forth? That's led us to have pretty narrow window pockets. We don't have really wide pockets. Most of our windows accommodate a 3/4 inch, 7/8 inch IG insulated glass unit. And consequently, because they're sliding past each other, that's sort of what the industry's developed around. We can now make it a triple pane without anybody having to change anything about their windows. All of our windows have wider glass pockets. When you go to Canada, all Canadians, because it's cold, have wider window pockets, much like Europe. They don't want to talk about thin glass triples at all. They do triples. All they want to talk about is thin glass quads. So that's it's actually pretty interesting. Now let's go to window retrofits, and we're going to come back and talk about our secondary window product in a moment. I talked to you a little bit earlier about what people do right now. We'll see if you can remember. What is the 3 most common ways people deal in the commercial world with retrofits? Does anybody remember any of them? Come on. Yes, sir. Film. I had no idea. It is a very mature industry. If you got clear glass in your single pane in a commercial building, whoa, I don't know how you survive that one. But they have film. What else do they have? What's that?
Oh, gas.
Yep. It's call it the weather stripping, but more importantly, big bottles of silicone going around the edges constantly. And what's the most popular thing people do to fix their windows? We don't really fix them, they just cover them up with window blinds. Here in Colorado, just up the street, Hunter Douglas honeycomb blinds, really good quality product. But when you look behind some of those blinds, whoa, shocking. But people can't see there, right? So I talked about the Empire State Building. That's a classic example of replacing glass. That was double clear glass. It happened to be really good windows. They were put in the 80s, still in really good shape. They're aluminum, thermally broken aluminum. I don't know why they put clear glass in back then, but it is what it is. But they were going through a major rebranding of the Empire State Building, and ultimately very successful, one of the most successful deep energy retrofits ever. And they dramatically increased the value of the Empire State Building. But as we pulled them out, that's a great example of why and where you could use a thin glass triple insulated glass unit replacement. Here you see an example. I've got a link in here. You can click on it, of a really deep and thorough study of the use of thin glass technology in lots of applications. As we began developing it, the Department of Energy became more interested in it. We were sending samples off to this vinyl window company to put in here, that vinyl window company put in there. We were sending samples out all over the place, as were other companies, I think. But one of the things they did is took what was a failed double pane IG unit, and they simply replaced the glass. Super inexpensive, very low cost way to upgrade a window. And all they were trying to do is, what are we missing here? And do the studies and provide the science. Worked great. You can get into the report. When would that be a good use? You've got to have at least, you might be able to go thinner, but we like to have at least 3/4 of an inch at a minimum. That's sort of what I call the sweet spot on the low end of windows. Some go 5/8. We kind of leave those alone. You want to do it in a building where you can either glaze the window from the inside or keep it under 2 stories, because this becomes kind of the cost goes way up if you're doing that. It's a great, fast, non-disruptive solution. You need to have a good window, though, a good fundamental window. If your window is in bad shape, it doesn't really help to replace the glass very much, because you're still going to have a leaky window that's in bad shape. But they exist. The biggest challenge here It's not that difficult to reglaze a window, but it's not something a typical handyman does for a maintenance group for an office building. So you typically have to order and organize a commercial glazer to come in and replace the glass. Doesn't have to be, but that's more common than not because of perceived risk. So that can dramatically, we know what the cost of a thin glass triple is. It's not very expensive. If it goes to a commercial glazer, they like to mark it up, and we don't really know what that cost is, but our guess is that all in typically it's going to be anywhere from 15 to 25% of the cost of a window replacement. And it fits in the same pocket. Window retrofit option 2, beyond the 3 I talked about already: film, cover it up with blinds, and then get your silicone gunk in there, is window replacement. I want to talk about when it works and when it doesn't work. Very big difference between what I call residential window replacement and commercial window replacement. For whatever reason, the commercial window world is much more heavily dominated by aluminum windows and has historically been. It's a smaller and smaller market share, but it's got a place because of perceived ability to be more durable for longer periods of time and to do bigger windows, etc. So you frequently find aluminum window systems in commercial buildings, but it doesn't necessarily have to be replaced with aluminum, but aluminum tends to be more expensive. When do you know if you need a window replacement? You kind of know because your window's fallen out, and you've got enough gunk in there where you can't do much more to it. So it becomes kind of a bit of a challenge because it's very, 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 can be very, very expensive. And I'll talk briefly about some of these market case studies that we're not going to go into, but I'll give you the links to. And it tends to be pretty expensive. I don't think you can get a window replaced in a commercial building for much under $750 to $1,000. I don't really know. Monsef asked me to talk a lot about pricing. I asked my colleagues, I said, we don't really talk about pricing, but I'll talk about it as much as I can to give you some basis in here. And that's not the cost of the window. That's the cost of a window plus getting it replaced. It varies dramatically. If you have large windows, you have to bring in a bunch of large commercial crews and equipment. The price can go up pretty quick. If it's a big job, they can leverage that. But the price of window replacement is not insignificant. It gets much more expensive when you have a challenging install and it's really, really, really expensive, almost cost prohibitive if you have a true historic window that you're working with. Because typically in real historic window situations, they want you to replace the look of the window, same sight lines, the same appearance. And there's a handful of companies that specialize in that, and it's quite expensive. And the biggest problem is I went back, if you have a fully occupied building, and a lot of buildings do, some don't, you can't disrupt the tenants and say, can you go home for a week? We don't really know when the crew's going to come over. It can be pretty massive. So it's a real challenge. Now we're going to talk about our windows in about 10 seconds here. We make several different window styles. We have a fiberglass window outswing. We call our Zenith series. It is, that's the first R10 full frame window to our knowledge in the world, using our high performance glass. In the high performance space, I mentioned that we compete all the time with European imported products. So one of the best ways to compete with them is to have a European style window. So best in class North American outswing. North American means narrow sight lines, outswing operation, awnings, casements, or frequently hungs and sliders, double hungs, single hungs and sliders. We don't do many because they're not really, they have more air infiltration. Or the European style. European style is what? Does it swing out or swing in? I don't know what they do. Yeah, no, they swing in. Tilt and turns, they tilt in and swing in. You can have outswing, but they're kind of famous for their tilt and turns and much wider sight lines. Then we have what we call our aspect series, sort of a commercial, more price point window that's very popular to give us lower price point, bigger window that goes outswing in places like Boston. Now my favorite thing. I've got 2 kids. I don't know how old you guys are. My daughter's 23, 22. I better get that right. My son's 20. And I've tried for many, many years to impress them, and it's really, really hard to do. There's not much I can do to impress them. But the founder of Alpen and I were co-patent inventors of this window. And I thought that would do it, but they were nonplussed completely. But and the whole patent process, you guys may be more familiar with it than I am. It is, for a history major, kind of a weird thing. We filed a patent on this, what makes it patentable, and I'm going to pass these around, be careful. This is a corner cut. My favorite sample I brought was a humongous windsurf, but I was intimidated by getting it from my car to this classroom, so I'm sorry, it's in the back of my car. But it's 25 square foot, it weighs about 26 pounds. This is the windsurf light. This is the windsurf plus. I'll show you what the difference is. I'll pass them around. Be careful, don't cut yourself on the windsurf light, but it is amazingly simple. And that's why I love it. I remember who it was, Galileo or something. One of those guys said simplicity is brilliant. But it is very, very simple. But what makes it patentable? It is the first secondary window with a high performance fiberglass frame system. We uniquely put film on thin glass so that we could add both solar control elements to it, and we could also provide safety glazing to it. And it's the combination of those two things that eventually the patent examiner, who first came back after we filed the patent and said, "This is so stupid. It's a storm window." We said, "No, it's different." They said, "Okay." They gave us a patent. So it is simple, but it's different, and it's the highest performance secondary window we know available in the world. A little bit of it is the outcome of that Empire State Building experience. We went and reglazed the Empire State Building. It was cool. It was fun. 13,000 windows. And said, why doesn't everybody do this? But everybody doesn't do it because they're not the Empire State Building. There's not that many situations that are identical to that have that opportunity. But we knew these buildings still have the same problem. So why don't we take our learnings on high performance windows and turn it into a secondary window? And let's do something different. Are we the first secondary window in the world? No, they've been around for decades. Most of them heavy aluminum, heavy glass, stuck to the inside. I don't really understand why you put aluminum behind aluminum, but it's a really, really, really clever solution. And all we really need at this point is 1 inch of solid clearance behind of the window. If you want to operate the window, you have to either remove windshirt. If it swings to the inside, not a great application. If you wait about another 4 or 5 months, now you can have a windshirt that opens to the inside. We're in the midst of developing. We're developing it because we're putting a double thin glass light in the sash to reduce the weight. In order for it to be effective, we have to get that low E coating on thin glass that we talked about that's now ubiquitous. We just didn't know, nobody coated thin glass in the world. So now we've got 2 suppliers that are supplying it to us. It's coming. It's going to be super fun. This is a very lightweight, easy install. We've got about $25 million of projects on the books for this coming year. Yes, sir.
Why are you calling it a secondary window? Is it an add-on to an existing window?
It is. This is why it's a secondary window. That is how it's installed. It goes to the inside. The primary window is still in place. It's going to the inside. You're not trying to rip the window out. You're trying to cover behind it. In the ideal installation condition, you're over insulating the frame. So our high performance frame almost always is able to insulate behind the non-thermally broken aluminum. My son did that animation. I'm so proud of him. Self-taught, but it's narrow. And this is a pretty common application. That's an old historic double hung window. You can't really see the windshirt in there, can you? It's almost invisible because it's coming behind the window. One of the most interesting things that we've learned as we've brought this to market over the last couple of years is the number of people that said, please don't ever let my tenants open a window. It's nothing but problems. We want them permanently shut. They need to look like windows, but nobody really wants to open them. It is shockingly common. Once again, it can be installed in a row of windows. It can be installed as a single window. There's about 5 major installation conditions that we have. I think we've put, I don't know, maybe 30,000 in the installed, kind of in many projects around the country, different applications. It's crazy simple, and it's Achilles' heel, as everybody thinks why is it so simple? Why hasn't everybody done it? But it's very, very effective. We have tons. We are kind of a nerdy company up in Louisville. We like our data. We like credibility. We like testing. We're testing. We like certified. We like to have, some of you like to be tested. Give me a test, give me a grade, tell me how I'm doing. We like to be tested. We like to have other people test us. We don't like people that cheat. We like credible data, and we are very, very proud of that. We post that information and we compare ourselves with other people. But it's such a simple solution that frequently people almost think it's too good to be true in a strange sort of way, but we're having great success with it. Once again, the super unimpressed children of the patent in 2022. It's a secondary window. What you're looking at there is in the Windsert Plus, this configuration, thin glass. It has a piece of film on it. That's a traditional low emissivity coated film made into a micro insulated glass unit. It's put into a very simple frame. We install it. It takes about 5 minutes to install. It's very lightweight, and it's lightweight because the cost of the unit is not really all the materials. It's the getting it installed. It's so simple that if people aren't familiar with it, they want to mark it up just to make sure they cover themselves. And it's crazy, crazy simple to install. You can see what happens. This is a thermal model of using the LBNL software, or Therm, I think it was, actually, of a non-thermally broken aluminum window, and what happens when you put Windsert Light and Windsert Plus in. There is now a rating agency we'll talk about in a moment. This is one version of it installed in my favorite picture in the Empire State Building. Once again, it's got good glass. Now the frame's not that great, so it's okay, but it's, what is it, almost 40 years old. We haven't done the Empire State Building, but we'll see. It's got this crazy red color. You may tell you a little secret. You can't tell anybody. Is this really recorded?
Yeah.
I should be careful about this. Yeah, I'm not gonna tell you a secret. Yeah. I'll tell you after they turn it off. But these are examples of the Windsert being installed here. Lots and lots of data. I won't go through this. It's pretty intense, but we've had great field verification of the results. They frankly have exceeded our expectations. We don't have the ability nor the patience to do this, but a lot of people that are supporting early science on this are studying energy bills in buildings, pre-install, post-install, and it's really produced some pretty remarkable results for the cost. And our costs are dropping now as we're going to scale, so the paybacks will get better and better. My favorite number, I have 2 favorite numbers. I'll show you when we get to these projects. Case studies, 915 Broadway, 5-story, fully occupied, mixed use building. We replaced all of those. Almost all the work was done in 4 days by 4 people in a fully occupied building. Even have a picture of a guy that was working at his desk while it was being installed, which I did not say was a good thing. You can go to these links and get detailed case studies of all of these projects. In this case, that building, they got 3 bids to replace the windows in that building. It's a 5-story. It's not that big. It's a pretty cool building. Vancouver, Washington is just outside of Portland. The lowest bid, our Winsert installed price was 12% of the lowest bid they got. They could not replace windows. It was just too expensive. Didn't make sense. So they were amazed by the results. My favorite story, though, is 2 months after the installation took place, we got an unsolicited email from the building manager that was kind of the head person there. So I just had to send this email. This is in the news all the time. They had just had a heat dome there. I don't even know what that is. But his email said that we just set a new record high temperature here. And I wish I had that. It's 109 degrees. And we shattered the record that was set 2 days ago of 105 degrees. And it was just, it had people dying. It was just a terrible thing. And he's an engineer. He said, this is my building. These are outputs from my building management system. And he showed the temperature at the edge of his building. He said, when it was 90 out, half of my tenants went home and quit working because they're just absolutely fried on the, it's pretty mild. That's Portland area. But it's like 72 degrees, 74 degrees. I just can't believe it. So this is crazy. So that's, and then the VA administration building got installed. Literally 3 months later, what they have in Texas, 20-degree temperature. People were dropping like flies. The energy grid was a disaster. Building worked great. That particular building manager had been there a long time. He took a little bit of pride in the fact that a lot of his fellow building managers had all their pipes breaking and shutting down. So it works. Other case studies, GSA Green Proving Ground. There's a lot of information out there. Other window treatment options. I just want to get through this real quick. Once again, we talked about them already. A range of options out there. Won't get into it. You can look at this at some time. This is sort of an effort to kind of talk about the different pros and cons of different solutions. This is focused around kind of why Winsert has worked so well. And some final thoughts. Some of you are studying energy modeling, I think, and that's part of this program. These are what I think are really important. I talked a little bit about the fact that we're nerds. Data is really, really important. A lot of people make claims. If they're making claims without the ability to verify and validate, third-party verify and validate, be worried and be suspicious. They should always have data. In the world of Windows, there's a lot of ways to measure performance, but in the United States, we all measure performance typically with NFRC ratings. It's a pretty rigorous test series where you get windows physically tested. You have to make sure your insulated glass units go through extended durability, but then we're all measured kind of the same way, so you know it works. Monsef asked me to talk about our performance. You can get all the details there if you want. Most of our windows are kind of start at R5, we go up to R10, we have R11, but it's kind of stupid. But we're mostly in that higher performance space. Glass replacement, you're probably familiar with all of the software we use every single day, that software system, because we're now talking to many, many window companies. What does your glass do in my windows? We have to talk about center of glass and their particular configurations. Secondary windows, this is really, really important. Like NFRC really started regulating for the consumer data about windows and putting everybody on a level playing ground. There's now a new organization called I don't know who picks the names of these things, AERC, Attachment Energy Rating Council, that takes secondary windows, blinds, secondary windows, other sort of secondary window features. And they've created kind of a level playing ground where third parties test your windows installed, so you know and can compare favorably. We like to point it out because we're the best, but it's a really, really important way for us to all regulate one another in what the performance is. So if you're working in your energy modeling with secondary attachments, go to the AERC. There's a lot of data in there, particularly around shades and blinds, that I think is really, really helpful. And it's growing quickly.
Good question, Brad. When you look at these reports in the NFRC or the AERC,
results? That's a degradation test over time?
No, it's a actual physical, based on a physical test. We take a window of a certain size based on whatever the operation is, send it to a lab, they put it in their big chambers and they actually measure how much thermal transfer there is. And then that's a baseline measurement. You model up and down from that baseline. There's certain rules on the secondary window. It's a 4x5 window installed behind a single glazed non-thermally broken aluminum window at a certain level, and they test it. Now, not only test it for the thermal performance in the whole window, but they also test air infiltration. And it's intention that they start with a window situation they can design to be exactly the same leakiness, and it's really, really leaky. And they put our secondary window, and they test it before and after. We reduced air infiltration because we have this gasketing system you saw by 97%. That's a really big deal. To my point, when you're talking about energy modeling, when you're looking at windows, don't always just look at windows, look at air infiltration, particularly if you're doing modeling. These are the things that are really, really important, I think, to capture. If you're improving the window, sometimes it's not a perfect science of how leaky it was, but take into account better than average air infiltration. In your models, you can adjust that. This one I really want to highlight though. If you're doing any energy modeling, you have the ability to adjust thermostat set points. When the $300,000 or $400,000, whatever it was, energy model for the Empire State Building model was done, we sent the thermal results over. They ran it through their little thing, but until they adjusted the before and after thermal set points on the thermostats, it didn't really pencil out, but it made sense. And it was through an ESCO, an energy service company, that had to guarantee those results. And it's been modeled year after year after year after year. And it's always exceeded the modeled results, which included adjusting the thermostat set points. If you have a really, really bad window, building, whatever it is, you replace the windows, you're not going to leave the thermostats at the same point. They're typically going to readjust. And we've put data loggers in all over the place. It just is a reality, but don't forget that in your energy before and after modeling. It's very important because people simply want to not ignore those two things. And I think that's just not appropriate. Then there's this weird squishy argument about thermal comfort. Do we really care about that? Or is it we're going to get paid back on our electric and heating bills? Thermal comfort's a really, really big deal. And it's dramatic. It's measurable. It's understandable. The software modeling will tell you what the temperature on the inside surface will be of your windows, if you're talking windows or glass, before and after. That's okay. It's really important. And then I'll stop. Thanks for the soapbox. This makes me absolutely crazy. If you guys are studying energy performance and you're in the engineering school, it's heat pumps, heat pumps, heat pumps, heat pumps, heat pumps, heat pumps. I love heat pumps. They're great. But people are doing this backwards. If you're replacing traditional HVAC with heat pumps, you're not dealing with the building shell over and over again. Number one, you're never going to do anything with the building shell after you do that. And number two, you've missed the opportunity to pay for your window upgrade almost every single time by reducing loads and then measuring it and then replacing the HV or the heat pumps. It now is expensive enough where it actually makes sense. And the finest minds I know out here are going crazy over this because it's hard to do the shell. So let's just do heat pumps because they're kind of cool and sexy. So I'm off my soapbox. And then finally, this is highly personal. But when you make high performance windows, it's one of the most interesting phenomena I know out there that everybody thinks you're just really, 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 really expensive. That's just not the case. It doesn't cost much more. We have different distribution models. Our products, other products, there's some scary, cheap, high performance products out there. Imported. You can put that on and emphasize that, run it at the beginning and the end. But quality doesn't mean that it should be not energy efficient or cost effective. It's just do your homework. It's the most kind of annoying thing that we hear over and over again. Oh, I thought you're gonna be real expensive. We're very competitive, as are many other high performance companies. That's it. I don't know how I did on time, but
You're good. Thanks.
here.
Yeah, we have 15 minutes of questions. If there are any questions, Brad, the time.
Yes, sir.
Earlier in your talk, you talked about how window pockets in the US are specifically thin, and that's why we don't have triple pane windows are not most
Yeah.
of the thing.
Yeah.
Has it ever been a challenge when you're installing secondary windows onto the same window pocket about not having enough space for you to do that?
Yeah, occasionally, it's more rare than we think, and it's usually because there's frequently, and it's not oftentimes people are boxing it out. I actually have only seen it a handful of times, and I saw it on a window. We don't do residential jobs. This really cool house, these really cool people. So, yeah, sure. Impossible to do it. They just didn't have space, but there's almost always space. The biggest problems are usually hardware intrusions on old hardware that's kind of got these weird things. But it's pretty rare to not have space for a secondary window. At least in our experience, I'd say the vast majority of windows do.
Is there a rule of thumb for how much less like thermal system capacity you need? So if you're gonna do the windows, then that system as far as
Of course, the right answer is it depends. If you have really bad walls, I mean, think about whether you want to spend the money on the windows, if you have R6 walls. But it's we can reduce the information we have is we can reduce heating, cooling loads by as much as 40-45% by taking a single pane with upgraded window. That's from the GSA report where they actually studied this stuff and measured it. I think that Vancouver building I talked about, we didn't know, frankly, that somebody was modeling it for the entire year after we were there. And they submitted themselves for an award for something called Retro 30. We congratulate them after they won, but they measured a 32% improvement in the building shell before and after for the first full year. That's significant. And really lets you modify it. The Houston job, they did it the exact opposite. They're one of they could have reduced the HVAC upgrade they were going through at the same time by more than triple what our product costs by what they learned afterwards. I would say in most big buildings that are going through major upgrades, you could easily pay for the window upgrade and be more comfortable. Anything else at all? Yes, sir.
It's last time to PV windows and what's your view on using PV windows?
We're being in a high performance space and being out here for a while. We've spent a lot of time with a lot of window technologies, and we've actually worked with 2 or 3 of the clear photovoltaic windows, and some of them have come and gone. Recently, a company that I showed a lot of promise, Ubiquitous, we actually put them in some sample windows. Appears they've gone out of business. So it's a challenging area to get enough efficiency out of PV, clear, transparent PV windows to really be able to integrate with building management systems. I think, and we've talked about this in the Best Center from time to time, I think there's really extraordinary opportunities ultimately for that science to create new and different ways for using that energy that's captured. Like building integrated photovoltaics, I think are phenomenal. The transparent ones are still challenging. There's companies out there that are doing it. And I just heard another 2 that have announced new products out there. And we've stayed pretty close in contact. We were pretty excited about working with one that had transparent film, but they just had to go out of business. We've got a Todd Allen. Considering your Texas and Washington case studies, sounds like you have the ability to make a thermally light building thermally heavy. Is that the case? Thermally light meaning poor performing, good performing. Yes, absolutely. Does it satisfy SHPO? And I don't know what SHPO, anybody know what that acronym?
Oh, that'll be, state historic preservation.
Yes, yes, it does. It almost typically does. We've done now 3 buildings that are on the National Historic Preservation Landmark. Hills Brothers Coffee is the lead platinum building that's a historic preservation landmark, and they did everything in that entire building except for the windows. They had 60 square foot hung windows from 1902 or whatever it was. Of course, we installed a mock-up and the historic folks had to find it and they couldn't find it. We have done tons and tons of what I call historic, because we go to the inside and almost always the historic buildings have wider pockets that you can't even see our product in. So it's very common. It's a strange thing too. There's a massive number of buildings in that era that also have curved architecture somewhere. I don't know. We invented that one. We happen to do a curved window. We've done some crazy curves. They keep walking in and saying, did anybody pay for that? Did anybody pay for that? But they always seem to. Anything else I can help you with? Thank you. Yes, sir.
Is it always worthwhile to add a secondary window than replace the existing window into something that?
No, I think it's one or the other. I think if you're going to put a secondary window, and you could, storm windows have been around for a gazillion years, and I think storm windows can do well. They frequently are, single pane aluminum. That's not the best. There's a lot of great products out there. I think you do one or the other. I think if you're doing a secondary window product, you kind of made a decision not to replace your windows, at least for 10, 20, 30 years. I think if you're replacing your windows, you sure don't need a secondary window. It's one or the other for sure.
So on that question, what's the cost differential between replacing the window?
Pretty significant. I would say, once again, the obvious answer is everything's relative. I would say that it's, when we came to market, we said it would be 1/3 of the cost of window replacement. I think it's, nobody comes to us and says before they get our price, this is what replacing our windows. We always find out afterwards. And it's been the 3 places where we found out, it's been about 10%, 12%. Yeah. Which I don't know if that's a reflection of the cost, but it's really, really challenging, these big buildings to replace. And then skyscrapers in New York, it's almost cost prohibitive, as you can imagine.
As far as kind of, making the order, providing the specs, is it just here's all the dimensions of our windows? Can you build these in secondary?
Yeah, absolutely. The running joke is we have not yet seen, with a secondary window product, we've not yet seen the same size window twice, and we've not seen a square window once, which you can see that gasketing on the outside. We've kind of gotten where you can kind of make up for that. It's sort of true, but not that far off of being really true. That's okay. It doesn't really matter to us. We make each of them just as fast almost.
Did you train the installer or what is the business model?
Yeah, it's interesting. That's a great question, Monsef. As we started to go to market, we have some installation partners in some parts of the country. In San Francisco, for instance, we've done a ton of the same buildings with an installer. He happens to be a film installer. In New York, we work with another company that's been a longtime partner. We have participated in install and probably 2/3 of the projects because we do it so fast and everybody is intimidated by it. We've gotten to a model now where we have mock-ups in-house and we've done assisted installs, and then more and more with a little bit of education and people with a little more confidence, they're doing it themselves. The model, it's really, really not challenging. We've got tools that if somebody wanted to buy it and they had a really pretty handy group and they had modest amount of confidence, they could do it themselves. And that's most of the projects we're selling we're not even touching anymore. So, but we can bring people in and teach them, and then once they see that, it's that simple, but it works.
I have one more. I know we have a project right now in the Best Center about kind of the hydrothermal condensation aspect of secondary.
Yeah.
You know, what are things maybe like that to keep an eye out for as far as like, maybe the downside,
Yeah.
things to keep an eye on once there's.
Yeah, that's a great question. Condensation between a secondary window and a primary window is, I would say, the number one boogeyman that people that understand the physics are always concerned about, because of the ability to trap condensation. And if you get the temperature change to have it, we've installed, I don't know, maybe, I don't know, 10, 20, I don't know how many we've installed, and we hear it all the time. And we don't see it very often. When we do see it, in the very few cases, it almost immediately goes away. So I don't really, that's why there's not much science around it. It's sort of theoretical, and we actually have a whole contraption in our facility to try to create it, to try to understand it better. We created ways to evacuate it, but that's a problem. I'm anxious to get our operating version in, because there's also the number one reason we don't make it to second base is people that haven't opened their windows in decades don't want to close off that possibility. They can't open their windows because they're so bad. And they sometimes say, the window can be taken out in 5 minutes and put back in, but nobody ever does. So that's a common kind of concern, I would say. Beyond that, I wish I would really love to come up with 3 or 4 other things, but I can't, because we've yet to find someone that's installed it and said, that was stupid. I can't believe I did that. It's just the thing that I wish and I regret we were not better at marketing is the number one comment I understand and I hear over and over again. And every time I hear it, I go back, oh, we're going to get this one. Is we install it and people say, in urban environments, people say, wow, wind's been whistling through. I'm so much more comfortable. It's always the same thing. It's so quiet. It's so quiet. They live with cars going up and down the roads and they just become so accustomed to it that they're oblivious to it. And they're just so quiet. Detroit has this spectacular, was the original headquarters for GM. It's called Cadillac Place. It's a spectacular national preservation thing. And they have single pane center pivot windows, and they were getting ready to spend $4 million just to replace the gasketing on the center pivot windows. Because the building was designed where there's like an 8-mile road or something, a road that dead ends into it, and it creates this wind tunnel, and it's a nonstop. It's always 8 to 15 miles an hour on that face, and wind literally whistling through it. It's the biggest, it's the state of Michigan employee, of course. We did 15 installs, and it was the comment everybody said, it's so quiet. So the wind, you can almost see your hair blowing before we put it in. It's so quiet because of that nonstop wind current. It's very interesting. But we put them in, and the little thing happened 3 weeks later, called a pandemic. So the entire building was unoccupied mostly since then. Anyway, well, appreciate it. Thank you guys very much. Appreciate it. Thanks. Appreciate it.
Yeah, I think we did.
I'll stop this and then we'll go tell that story.
You tell you,
Yeah,
I'll tell you the secret. Tell you what I'm telling you the secret.